Hello and welcome, everyone. My name is Peter Robinson. This is the Ethereum Engineering Group meetup. Today we've got Dennis Verstappen, and he is going to tell us all about Ethereum data and how you can get that, process that without using subgraphs. So an alternative to subgraphs. So Dennis, before you lead off on your talk, would you like to introduce yourself?
Yeah, absolutely. So I'm Dennis. I'm head of research at the indexing company. The indexing company is has been around for the last 2, 3 years, and we're trying to focus on the data problems in crypto. Right now, we're building the neighborhood, and the neighborhood is a data processing network that processes all data from all these different chains, and it's as you said, an alternative to subgraphs, but it can do way more. But more about that later. I've Before I joined crypto around 2018, I was a data analyst in human resources, market research, and when I went into crypto, I wanted to do more research on data itself, but I had troubles getting that data, or especially at scale. I had to either like tap into like APIs or didn't find the data I was looking for, while I assumed it was all on chain. I could read it from a block explorer. So I figured out there's something that could be improved in the solutions that fetch that data from these different chains. So that's when I started doing more research, and then I met Brock, the founder of the indexing company. And fast forward almost 2 years now, we've been building this product together.
Hey, brilliant. So, yeah, that it sounds really good, and it sounds like you're well placed to give this talk as well. So, can't wait. So, please, show us your slides and your demo.
Absolutely, yeah. Let me get that on screen. There we go. So, as said, we're building the neighborhoods with the indexing company. Um, but let's start with what's happening in crypto all the time. So every crypto company and basically every developer in crypto needs on-chain data. It's on the blockchain, it's publicly available, but getting that data is often a costly process. If you do raw RPC calls, you still have to filter, you still have to call that RPC for historical data, and you have to do the decoding, and then after loading it, you have to do all these transformations. So what crypto is actually missing is a bit of like an ETL pipeline that a lot of data engineers or developers would know in Web3 if they worked those jobs before. But right now in crypto, people are often just reselling data. They put it onto their network. That's what a lot of the decentralized solutions do, although in my opinion, they're not really decentralized. It's still a very centralized way of like storing data and then processing that actually locally. Um, but they store it on network, or they store it in a database, and then it's often better structured. But now you have to ping an API to fetch that data, and that data isn't fitting for your model. You have to transform it a lot, and it can be super costly if you want to do that at scale. So the alternative is what these companies do is they build it in-house, and they spend like thousands or even millions for some companies at a year on having that data infrastructure, getting access to the data and processing it after. Then they have to build their own tools. And there's a lot of elements to that that can break at latency. And then I think one of the most underestimated problems is that there is a lot of a shortage of good data engineers and people who understand the data from all these blockchains. So what most indexing solutions do is they spin up a subgraph. Nowadays, we also have streams that work from those graphs or its APIs. The problems with that is that if you have to change your pipeline. So let's say you're listening to one contract and now I need to add another one. You have to re-index, you have to load it again in the subgraph. It might have downtime, and it gives you a very specific schema, which you then still have to pull from that subgraph or retrieve from the subscreen and then transform after. So there's latency problems, there's redeployment problems, there's some downtime. And if you now want to do that at a multi-chain scale, that becomes a problem, because now you have to run like tens or like 20 subgraphs. So what we've did with the neighborhood is we've built a network that basically listens to more than 120 chains. And that network just focuses on processing that data. So it's basically the ETL for crypto, where you take a raw block of data, you transform it with JavaScript, and you have full control over which contracts, which events, and then you can transform that in the same step. From there, we can send it to wherever these developers want it. So it's often a Postgres database, but it can also be a Kafka stream, or you could do it like towards a BigQuery or webhooks if you want to do alerting. And that way you can make it fit for a very small use case. So let's say alerting, you just want to have alerting on one smart contract, flows that are above like 1 million from like maybe a stable coin, or you can ingest the whole chain into your own database. And one of the benefits of this network is that all these small nodes are processing that data in parallel. And that way, the no chain or no block is intermingled with each other. It's like you can do this at scale for all these different customers that use the network because everybody has their own logic and that gets sent directly to them. So the result from this is that we now have more than 120 chains onboarded. It's regardless of VM, so it's not only EVM. We can also do chains like Solana or MoveVM. But of course, what we see being used more or most demand is for EVM chains, which also makes it easier to make tooling for us because now we can focus on filtering on events, decoding those events, and picking exactly that right data out of the raw block data. We can also, for example, do metadata from a block. So that is often something that people don't store, but I think a lot of builders, sometimes validators or analytic systems need. So some of the use cases that where this can be applied is basically anything that needs on-chain data, but wallets, of course, are a good point for a user. Like if they ask us, what do you need indexing for? Wallets are often a good starting point because they want to see their own transactions, they want to see their holdings. Trading systems, there's a lot of interest now in low latency trading systems from these chains. There's arbitrage opportunities between chains. So we're focusing on also solutions where we can do very low latency, especially with the mini blocks and like the small shreds coming in, where we want to run indexers locally next to the node and pick up that data directly. What we're also seeing is there's more dApp chains, so you need very flexible infrastructure to tap into those chains. DeFi protocols are often like a classic use case, so we pick up the events and these smart contracts specifically. Agent systems where agents need contacts or they do something on chain. So they have to listen to on-chain events, act on it, and then that activity that's on-chain, they'll pick it up again. So on both sides, there's indexing needed. And with these flexible pipelines, you can actually start listening to all these new agents quickly. So you just add a new wallet to that pipeline to monitor, and suddenly that's a new agent you're listening to. And then finally, analytics and monitoring. If you want to do alerting, if you want to build your own dashboards, you need this kind of ETL. So that's it already for these slides, but I want to do a live demo. But maybe Peter, if there's some questions beforehand, I can answer them.
Yeah. Yeah, so I'll open it up to other people first. Does anyone have any questions? Okay, whilst people are thinking about questions, so I'm just trying to think through the actual architecture of your system. So is the idea that, say with a mutable chain, we've got, essentially a blockchain, you could think of it as, and so we would run a node as part of the neighborhood that would like sit next to one of our nodes on the network, and that would pump data into the neighborhood network. Is that how it works, or?
That is actually spot on to what we're building out. So yes, so for now we just run the network internally, but we're opening up right now. So what will happen is there is a lot of access compute basically everywhere in your browser, but also let's say on a validator node. So you have this server where you have your node running, but you can install a neighborhood node next to that, which only taps into that compute when it's an access. So um, it's more of a coordination mechanism to see like where that compute is available, and now can use that to take data from blockchain. What is different is you don't have to source that data directly from your own node. That can happen if you want a very low latency indexing. Um, but what we actually can do with this whole network is we could source the data, like the raw data from somewhere else, send it to that small node, it processes it, and then sends it back to the network. So that could even mean that you run an Ethereum node, but you're processing data from Arbitrum next to it. It's just that we can then tap into that compute. We can reward those users for it. But even better, for example, if you want to, let's say, get the whole history of Ethereum, you can, of course, get that from your own node, but you're very limited in throughput. What you can do is ask the network, this is where it has to end up. This is my database. And it then sources that from all these different nodes. So your node might take part in that computation for getting that data, but it sources it from maybe like thousands of other nodes too. And then with that parallel processing, that means you can process this data very fast. So for example, we've done backfilling for Ethereum in under an hour, like the whole history of the chain, which is often I think that's probably the quickest we've seen.
Mm.
And then often the bottleneck is actually the database on the user's end instead of the network, because it like scales linearly that compute. So there's even more innovative things that we could do is once we have more and more nodes in this network, we eventually can do like dashboards that are databaseless, where you just source it from the raw block data, transform it on the fly, and then send it to the database without needing the data infrastructure behind it as a database where it just sits. So that's quite unique. But yeah, for that, we just need to open up the network. Others need to come in and start running these nodes.
Yeah. Okay, Lecky, please ask your question.
Hi. Just want to more clarify in comparison to the subgraph you mentioned. Um, is that my, let me know if my understanding is correct. Is it like for subgraph, you need to put in the query so that it will only fetch for the specific information you want, which the pros will be like the storage will be less because you're only storing the data that you want. But the cons is like like you mentioned that every update need to index it again. And on the other hand, in your system, it will be storing everything so that it doesn't have this weak indexing. So my question would be like, firstly, would that mean it would take like the downside would be it takes more space? The second question is yeah, I forgot. Yeah, maybe just this one. Yeah.
Yeah, so just to be clear, you don't need to store all data. It depends on the use case, but in some cases we actually store less data than a subgraph. So how basically a subgraph works if you launch one is you put in a script that starts the indexing. The subgraph is basically just a database that is hosted for you with limited control over the data schemas and the API. Like the API is always GraphQL, but it doesn't respect any query patterns into that. You can do that a little bit in the script. So the script defines what you want to index. That can be contracts, certain events, like an ABI. But then it's always in that structure. A lot of subgraph solutions, you just like give the contract ABI and then it prints a lot of tables, which you never need. So there's also a lot of access in holding that data, even in a subgraph, even if it's a small contract. And then you have this very specific database for that one use case, and now you need to pull that data with an API. Of course, that's been solved already a bit with stuff like substreams from some of these parties. But then you basically process data from the blockchain, you put it in a local database, and now you have to pull it again or stream it again to another database, which is weird. So what we're trying to do here is skip that whole step of the subgraph. And then the only thing that matters is the transformation being done. So that script. So what we do is we listen to the raw block data. We do the transformation and the JavaScript code. I'll show you in a bit during the demo. And then we put it directly in your database. So there's no storage in between and no query layer in between, but now you can put it in your own database, and that's where you have all freedom over what to do with the data, into what data schemas you put them, into what queries you can run, how you expose that to the rest of the world, where it's like just with SQL and a database connection or through an API if you want to try to have that more public. Different ways to interact. So it's in a way we try to, meet you where you are, where you want to have that data eventually anyway. Yeah, and one of the benefits is like if now that data pipeline is just running over like raw data, now you can actually start changing that pipeline on the fly. You can start adding events, and then the next block that comes in start indexes that event. So let's say a new user connects to your application. You already were monitoring like 10,000 wallets and users for your application. A new one connects. You now have like a new wallet you add to the list, and then the next block that comes in gets indexed automatically. You don't need to redeploy. You don't need to filter after on the query. It's just like you get the new data in your database or wherever you want that. So yeah, but I think it might be good to show one of our examples right now. We have on the website docs.indexing.co. We have examples where we go from the whole flow from the chain to the database. And one of the first step is basically setting up a contract address filter, which is basically what we're going to do here is we're going to index Aave on Ethereum, and most transactions on Aave just go to the pool contract. And if you index the pool contract and filter on that, and then listen to certain events, you basically have most events you're interested in for Aave. So let me quickly show you the Aave pool contract. It's this address on Etherscan. You can see important events here. I'll zoom in a little bit. Repay, supply, withdraw. So some major events, and it is decently active. So that also helps us. And it's the pool v3 contract here. So the first step is basically creating a contract filter. And it's actually super simple, where we just insert data, which is that contract. And now it starts filtering every block on that value. So if a block comes in and doesn't have that address as a value in there somewhere, it skips the block and it doesn't process that for your configuration, basically. So let's start deploying that filter, basically. So this is the filter. I can also try to increase this a little bit. Here you go. You send it off. It says success. So now we have a registered filter. Then the next step becomes you can get the filters just so you see if it has processed. So we process that. It says like, hey, we're listening to this data. So that's the contracts filter. The next one, and that's basically where the magic happens, is we do the transformations. So we have this transformation code here, which listens to that block. So the block comes in here. It goes through all the transactions, even goes through the logs. And then this is where we built some tooling to just listen to the logs directly and see which events. So it matches the event signature, the encoded version with the version in the block, sees if that is one of the events we're interested in, and then decodes that. So now we're not only listening to the block, but also filtering on specific events we're interested in from that specific contract. And then we can also process that and put it in a format that we want. So this is basically our data schema that will be put out to our database later on. So we have the block, we have the chain, we have some transactions, and that's the data we're basically getting from this pipeline. So it's only a few lines of code, but then you already have basically a pipeline. What I can deploy that, I can test that transformation. If I send this off, I basically test this on this block on Ethereum. It adds that filter from that contract, and now we're getting some data back from that specific block. So if you know a specific transaction, you can test against that. Like, hey, I know I'm interested in this transaction. Does my logic work to pick that up? And we have the reserve data updated. We have a liquidation call. So that way we can actually verify this is correct. There are other ways to do this. So for example, I can take this event and this function, and we have a console.indexing.co. We can go to Ethereum here, and now we have a more like interactive version. So you can see what's in the raw block here, but if I execute this code here, it should start finding the last block where some of this data was in. You can also preview a certain block number if you really want that. but now it's just like picking the last block. So now we see that one of the last blocks, which was this block over here, contained the reserve data updated and a borrow event. So with that, you can also verify if this code is working, but you can also start changing that. So let's say we might not be interested in the block number, or I want, let's say I don't need the lock index here. I take it out of the code, I execute it again, and we directly see the pipeline being updated because the lock updated is now gone. Or if I want to do like decoded data or chain name, something like that, we execute that and it directly updates that in. Oh, there's no block coming in here, but here we have it. We have decoded data and we have chain name basically. So that's how fast you can apply these transformations and basically redeploy that then with these APIs. So that's what we're going to do right now. We're going to register the transformation, and that actually deploys the transformation itself. So the transformation we just saw, now it's available. And then the next step here is basically what I should do to get it into my database. So now we're actually sending it off as a pipeline. We're deploying it right now. And let me quickly see. Yeah, it's deployed right now. Because it's enabled true. It's also true for Polygon. I added that in here because there might be more events coming in. And then in a bit, I'll show you that in my database. But we already basically went through all these steps. We tested the transformation. We registered the transformation. And now we're going basically to part 2, where we send it to a database. I already set up the database itself with a table, but luckily in this tutorial we have an example how to set up the table, but you can basically just define basically this is the data schema from the output. So your output is just your data schema. So that's how you can alter those transformations to make sure you end up with a data schema you want. And then finally, we deployed it, and now it's going into the database. So let me quickly share another window where I have my database over here. There we go. And now there's basically data coming in real time from these different blocks. So if I refresh this, we now see new blocks coming in, with these being the latest. Let me quickly get that number into my block explorer. It's funny enough because like Etherscan at this moment, I'll drop it in chat for maybe the next block that comes in. Says this block is still unfinalized, but we already have the data here in the database. So the indexing is being done now faster than Etherscan can load that data into the block explorer. So one of the use cases with this technology is like we can actually power block explorers. We have done that for the block explorer once upon, where we did around like 22 chains at some point in real time, and then combine it with various other data points. But yeah, I can quickly send a transaction here in the chat. Let me quickly see. So the transaction I just copied. Like that's one of the transactions that's being indexed at the moment. So yeah, that's basically a whole pipeline. Yeah, I can keep refreshing it. I think for now only Ethereum is coming in because I haven't added the Polygon contract. I think it's a different one for Aave. But the Ethereum data is coming in real time. Are there any questions on like this demo or what can be done with the transformations?
Uh, I'll go first because Um, say rather than just the list of, the events or, as they're happening, if I wanted to have, say, what are the outstanding payments owing on that Aave contract? So, not what's been open and then closed, but, what is outstanding? Is there a way of, processing the events and then, like just having the net effect?
Yeah. I mean with uh yeah. So basically an aggregation on the database. What is that what you mean?
Yeah, that is what I mean. Yeah, so for
Yeah.
instance, yeah, anyway, yeah, aggregation on the data and processing of the data and then just having the output of all of that.
Yeah. So one of the things that we um what we offload basically is the responsibility of the storage. So
Mm.
um, uh, normally you would store the data into a subgraph and pay for that storage. But now you're responsible for that in your own database. But you can do similar things in your own database with these aggregations. So let's say you're indexing this Aave pool and you want to compute TVL. Well, then we backfill that whole pool, which is basically the same as re-indexing that according to that data schema. We keep on the real time too. So now you can also have the updates. And then that TVL, that aggregation is basically just the 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 aggregation of all those transactions in that pool, specifically for a certain token or even maybe that user. But those are the query patterns that you can optimize for yourself depending on your own needs. But that also then means is like you can use that for analytics like this. But also if a user is connected to your dApp or your front end somewhere, you can just listen to the single transactions. So um, it's a bit of a combination of like single transactions that are coming in or those aggregations. But in general, that means you can be very flexible with that data. If you own all that raw data in-house, you now have the freedom to do with it whatever you want. Whether it's aggregating, listening to single events, putting triggers on top. And otherwise you would have to build that after, you pull it from an API or pull it from a subgraph. So it's a
Yeah.
slightly different way of thinking, but once you get it, it's I now own my data and I now can do whatever I want with that in my applications.
Yeah. Okay. Are there other questions before I fire some more questions in?
Yeah, maybe I have to add something to this. So one of the things I mentioned was the databaseless processing.
Mm.
Um, what we eventually can do, and we actually have done it internally with our network too, is let's say a wallet holding. So normally the holdings in your wallet is a sum of all your transactions
Mm.
on EVM. What if we can get you all your data on the fly without storing that in a database and then having to aggregate that? So basically do the aggregation step in the network. Normally this would look like we load all the data from this wallet. We then aggregate that as a second step in the database and then expose that to developers or the user, and now they can see their own holdings. A lot of solutions now have to just like expose that as a materialized view in a table and then resell that. But one solution we've built is what if we can just source all those blocks in the fly, then do that aggregation step again in our network and just give you that data, which then means we can not only give you the wallet holdings, but also specific coins. And it's just like processed from raw block data. And we've done that at the speed of APIs, where the network just processes it. And that's only possible because of that parallel processing. So that is a simple use case, but we want to go deeper. But for that, we need to have access to more parallel compute and more people to start running these nodes. And that's still in development. We're actually raising a round right now to continue doing that. Otherwise, we'll get there just through normal means of business, like running the servers for people and then develop it with them. But yeah. It's on the roadmap to build that out for them.
Yeah, okay. And yeah, Mark, go ahead.
Thanks. Yeah, sorry, I missed the start, so hopefully you haven't already answered this. I was going to also ask the aggregation question, but often the aggregation's done, like you get lots of events, but the events are talking about maybe progress through a state machine or something, and you want to know the current sort of state of the contract after it's been through those various events. But the other kind of aggregation you get is like just in terms of reconciliation for like transfers or whatever for balances. So that was, but I think you've kind of answered that already. What you're saying is that the client does that in the database just themselves.
Yeah, there's multiple paths there. Like if you want to get the current state, I think in those like those questions, you could also just ping the contract itself, right? Like there's often methods where you can get it. What we have under the hood exposed to this network is a huge aggregation of like all these different RPCs. So we sometimes have done that, give customers access to that RPC layer, and then they can ping those methods. What we even better can do, we don't have that fully exposed in this, like in our documentation, but we've built those pipelines where a block comes in, needs additional like metadata or data from an on-chain, does async RPC calls and merges that with other blockchain data. So we definitely have the option to do basically API calls in this transformation layer. It might slow it down a bit because then you have an async request. But you sometimes don't have to hold the whole state to do like fetch that data.
Right. But sorry, and maybe, and this is probably something I missed, but is this just event data, or is there also a way of kind of accessing debugger level data from the EVM execution? Like
Is
the
that
state
like
of, like one thing I'd often like to see is like, what's the state of this mapping at this earlier time or whatever?
yeah. I might wanna, feel free to send me an email with a specific example because it's
Yeah,
very often very
sure.
specific on how to solve that. So sometimes that is actually having the whole state in your database and then basically replaying that or querying certain
Yeah.
moments.
Mm.
Sometimes it is a combination of pinging the contracts and then getting the data and
Yeah.
then basically build some of the calculations that are happening on chain, off chain.
Yeah.
So yeah, it's I can't really answer that,
Yeah.
but
Sure.
it's all an option, and yeah, that's where we do a lot of conversations with builders, like how do you
Yeah.
get there with this
Yeah.
tooling? It's not
Yeah.
only events, no, it's like anything that's there in the raw block. So let me quickly show you that here. If I go to the template full block, um, wait, let me just reset it and do it again for Ethereum. Everything that's there in the full block we can fetch. So here it returns a full block. So here you have like header level data. We have here transactions in this block. We have the receipts, we have the traces. There's often builders that are in need of those specific traces. Like all of that data, that's what we
Yeah.
can fetch. It's just that a lot of builders are mostly just interested in the specific events.
Yeah.
So we built some tooling to like get that out.
Yeah. Okay. One perhaps easier thing that it would be, I think for this would be very helpful for as well. Like if you've done a API update and you've changed some of the event parameters or whatever, but you want to get a kind of consistent view now of across both API versions, then these sort of transformations, I guess you could build that sort of unified view fairly.
Exactly. Yeah.
Yeah.
And that's you're tapping into a major difference with subgraphs if then you have to like do the ABI change, it start re-indexing, it might not match up anymore.
Yeah.
With this, you can just say like, hey, I have this event signature might change, but I still know it's like the withdrawal event.
Mm.
So now you can also different ways to express that, but you can always say like, hey, it's just the withdrawal event and put the data in this column in my database. It's the same. Um, or create a new column in my database that is like second event.
Mm.
Just depends on the query patterns, but at least you have the
Yeah.
freedom and you don't
Yeah.
need to
Yeah.
re-index. You can just like switch on the pipeline, and from now it's like different schema.
Yeah. Yeah. Cool. Thanks.
Okay. Lecky had the same question I had, and that's cost. So I think he's probably thinking DApp cost, if if I'm an application, how much does it cost? And I guess as well, if I'm got a brand new blockchain, new roll up or whatever, how much does it cost anything to have your chain added to the chains that people can get data from?
Yeah, it depends a little bit, but for example, we already have like 120 chains. So in a lot of cases, highly likely that the new chain is live, already being indexed. But if you want a new chain, we can basically onboard that within a day. Um, what we do for real-time indexing is we do basically without cost, unless you really want, you know, tens, 20s new chains added, like that's a different skill. But if you want a new chain, just let us know and we'll add it. Um, because it's fairly agnostic in what data comes in. Of course, it's optimized for some EVM with some tooling, but we can also do the non-EVM chains. So yeah, there's not really a lot of cost in attaching a new chain. In general, our cost model for a builder is basically how much blocks are being processed. Like that's regardless of chain. So that's why that filtering and on certain events, contracts, or wallets is super important because if data is not in a block, we don't process that, and thus it isn't the cost for running it through these pipelines. And thus, it's a very efficient model. You only pay for the processing that is um, is being used by you and the data you're receiving. But then also if you need more or different data from a block, so let's say you're indexing Aave and Uniswap, and they're both in the same block, like there's Uniswap trades and there's Aave withdrawals or transactions, you only pay for processing that block because we're looking at the data anyway and picking data out. So this is where it becomes very scalable also in costs at scale when you're interested in different sources of data in like these pipelines. But even if you're like a small builder and your dApp isn't doing a lot of transactions yet, you only pay for the blocks that are being processed. So it also scales with on-chain usage for you as a developer. So there's definitely some use cases where builders only pay a few, 10 or $20 per month because they don't have a lot of data to monitor. That's why we've built a self-serve, like with the documentation. They can just get an API key and serve these contracts, events, and just get a pipeline running without us having to intervene. But of course, we're always open for questions. Yeah.
Okay, fantastic. Makes sense. Um, yeah, okay. So I think you've answered the questions I had. Are there any more questions for Dennis? Oh, well, looks like everyone's happy, which is good.
Awesome.
Yeah. Um, so why don't you present those last few slides so we can talk through what's coming up next. Yeah. So there is a merch store, and yes, so please, if you're after a new t-shirt, this is the place. Next slide, please. We've got some talks coming up. So in golly, just a week's time, I'm going to have to get my skates on. I'm going to be talking about 7702. Yeah, so that is the new EIP that's part of Pectra. And then after that, we've got the Circles Currency Protocol, which is a new thing, which should be interesting. And then we've going back to our DeFi and openness and crypto roots of decentralized communities. So valuing invisible work. So I think that should be really good, really invigorating. And if you are watching this and you're thinking, hey, we were developing some interesting tech, we should have a talk on the meetup, please get in contact. And maybe you can be 2 weeks after September the 24th. So there. Next slide, please. Yep. And those are the social links. So if you're watching this on YouTube, you can join the meetup and ask tricky questions live, which can be helpful. There is a Slack workspace, and from time to time there's example code. So yeah, you can get that there. And that's it. So thank you again, Dennis. That was a fabulous talk. I think everyone has learned about a new technology, so that's great. Thank you.
Awesome. Yeah. Thank you for having me on here, and thanks for listening.
Yeah. All right. Well, with that, I'll see everyone in another week or so's time. Bye-bye.